Good morning. How are you all doing? Okay, this is a small group of people, and I'm that presenter. So let's try again. Good morning.
Good morning.
Thank you. Hello, I'm Laura. Thank you very much for being here today. Now, the thing about being a security person at a dev conference is if you're in this room, you've made a very conscious decision to be here. So, well done you. And if you're not expecting a security talk, this is going to be a wild adventure for you. So, a little bit about me. I've done a few things. I wrote a couple of books. My mom is very proud of me. I have been doing application security and software engineering for more than 20 years, but I'm at that age now where I just disguise it with hair dye and crippling anxiety. So, I do a lot of conference talks, and I run a business. You may have seen me out on a booth. Now, I'm going to start with a very, very explicit promise. I'm not here to sell you anything. Not at all. I'm here because I love what I do. I'm here because I'm genuinely excited about all of the software we're building today. Raise your hands if you were that nerd growing up, was reading books about sci-fi things or watching movies and going, oh my God, the future's amazing. If you didn't, why are you in software? My goodness. For me, it was this exciting world was going to emerge, and I thought it was going to be long after I was dead. Turns out, it was 2 years ago. So, now we have this wonderful future, and it's AI everywhere and whatnot. We get to do part of it. We get to be part of that. And I think as a security person, I have to be excited about it. You cannot protect something you do not care about. Simple as that. If you've got an old jacket that, it's a bit ragged and you're like, oh, don't really care anymore, and you leave it on a seat and you won't go back for it one day, you're just going to go, whatever, someone else will find it. Software's the same. So what are we going to do in this talk? Well, I'm not here to talk about security tools. That's a bit unusual in a security talk. How many of you have an AppSec program or a person that's like, they're my security person and I love them dearly? Any of you are the security person? Oh, I'm sorry. Please make friends with your security people. They're very lonely. Right, we're going to talk today about how, as engineers, we can use the data we already have to do security. Now, I think that's really, really important because particularly this year, none of us have budget for anything. We have less people, we have way more to do, and yet we still have to keep all of this wonderful software safe and secure. So, how are we going to do that? Well, I'm going to show you how to use data you already have to predict application security issues. I'm going to get you thinking about your data and your tooling differently, and your projects. And I'm going to give you homework. Kind of sorry, but really not. Now, if anyone is in the audience is the type of person who is looking for a new hobby and likes writing open source software, I'm also going to set a challenge. If you come and find me afterwards, either in this room or at my booth, the contents of this I'm in the process of turning into an open source tool. And you know who the best people to write open source security tools are? The developers who are going to use them. So if you feel inspired, please do come and say hi, and I will put you to work for free. That's fun, isn't it? Right, okay. So the power of developer-centric data. This is an SDLC. We should all be vaguely familiar with it by now. The thing is, it's not really how we make software, and it's certainly not how we secure software. Let me talk about it. In a software team, you want to go as fast as possible and do cool stuff, and when something sucks or is painful, you want to make it go away. It's pretty much how I'm wired as an engineer anyway. The reason I really got into software was because I got bored of doing repetitive tasks, and I wanted to make myself redundant, because if I did that, I could do more interesting things. And that is the core being of being an engineer. Cool problems, and you don't have to do them repeatedly. Now, I'm a bit of a split person, because the other half of me is a security person. So there's one half wants to go fast and break things and do cool stuff, and the other half is like, you should really slow down a bit, and have you considered health and safety? And easy, tiger, slow. It's really hard. I want to both build amazing technology and also protect it from harm, and spot when bad things are happening, and respond to them quickly. And that's what we have to balance, that tension between the two, that friction. Raise your hand, and no judgment. You know, you're only being recorded for the internet, but they can only see the back of your heads. Raise your hand if somebody has ever given you a security requirement and you've been like, oh my God, this is going to break everything. Security people, if that was you, we don't judge, but we can do better. What we do right now in security when we're looking for data is we get it from specialist tooling. And that specialist tooling tends to be stuck into the SDLC, whether you've gone DevSecOps or not, somewhere in your build pipeline. So somewhere between you write some code and that code hits the production environment, that tends to be where security lives right now. Now, I've done many, many talks on this topic, and you can go and see those on the internet for free. And there's lots of reasons why this is a problematic approach. But from a data perspective, it's also horribly limiting. And I'm going to show you some biases, some reasons why we need to stop doing this, or at least we need to do something a little bit more. This is what security teams think software looks like. One nice, polite little repo. Everything's green because it's running, it's building fine. All of the tools run on every build. Fantastic. How many of you have tools in your pipeline that scan stuff and then tell you you're a bad person or your code is ugly? Yeah? So we do this, great. But that's not really what our software looks like, right? Unless you're Facebook, like the giant caveat, and if you're doing the meta thing of the giant mono repo, please don't. Even for them, that's a strange thing. But for the rest of us, we have lots of software projects. And depending on your industry and what it is you're building, depends on how complex this is. And if you're in an organization that grew by acquisition, for example, some of these things you wrote, and some you inherited. And some were written by people you know now in the organization, and some were written 20 years ago, and nobody really knows how they work anymore. And that's what software is. In secure development, we currently focus very tightly on the what of software, the lines of code you've written, not the process, not the ecosystem your software lives in. And that's what we're going to look at with this data today. We're going to move from this implementation-focused security, where it's all about the build, to looking at our ecosystem internally to us and saying, well, can I spot problems that mean my software is likely more insecure? Now, spoilers, by doing this, you're not just going to improve security. You will also increase resilience, you will upskill your team better, you will create more engagement, and you'll find opportunities to simplify your architectures. But I'm biased. I'm just going to talk a lot about security. So the bias in our security tools is that all software projects are in active development. So if you've bought a SaaS tool, it runs every time you build. Now, when a project goes out of active development, it's deployed in the world, it's doing its thing, it's not necessarily still being built. That's sort of the point. You finish one thing, you move on to another. And if you've listened to Sam Newman talk and you inherited the idea of microservices and you've gone all in, that means a large chunk of your architecture, your software architecture, isn't being looked at. Raise your hand if there is at least one repo in your ecosystem, inside your organization, that you have absolutely no idea what it's doing, and it terrifies you, because one day it will break. That's it. That's everywhere. So that's our first bias. We only run security checks on things in active development, which means everything else, all of that other software, is becoming dormant. It's becoming stale, brittle, fragile. So we need to remember our ecosystem doesn't look all green and healthy. Some bits are red and horrible and terrifying, and some bits are gray because they came with a package deal when you inherited a new company. And some were written by an intern who's long, long gone, who hopes their code is no longer on the internet, but would be very, very sad to know it's still in production. Our second bias is that our software projects are independent to each other. We spend a lot of time at the moment talking about software supply chain security. And that's the idea that the packages you build from come with security vulnerabilities and risks, and as a result, you inherit those. So we should be mindful what we inherit so that we can stay safe. But what if you're inheriting internally? What if the packages you're importing are not from, some big open source project? They're from the team 2 desks over. Because our software looks like this. We call things, we inherit things, we create processes that send data from one thing to another. And so when we treat our repos or our projects in isolation, we lose the context, we lose that interconnectivity, and the risk seems much smaller than perhaps it could be. Our third bias is that tools are consistently applied, or processes are consistently applied. Raise your hand if you're a senior. Any seniors here? I know you're a senior, because that's why they sent you to a fancy conference. They don't send many of the juniors here. Now, I want you to raise your hand. If you're feeling brave, do it for real. If not, just do it in your heart, and we'll all know anyway. If you know that if you wanted to, you could ship code and skip the pull request process. There you go. I like you lot, you're honest. Absolutely you could. But you don't, because you're good people. The fact that we're able to do that, the fact that there are people in our teams who, if need be, can go, actually, I just don't want to run that scan today, just skip. That's a bit of a problem. Because if you can skip it, if it's optional, it's like me going to the gym. If I can skip leg day, I'm going to do that, because I'm lazy and I like chocolate. So suddenly, we've got these processes that don't happen consistently. We think they're going to run every single build. We think we're going to be perfect, and they don't. And then we call things legacy. I love the word legacy. How many of you have a legacy system somewhere in your mix? Today's code is tomorrow's legacy. Anything you're not writing right now starts to fade. And we call these legacy systems separately. We say, oh, well, that's the legacy bit. We can't really do much with that. But it's still out there. It's still a risk. And it's not legacy in a sort of like vintage, look at it in a museum way. It's like an old car that you've got to keep it running, because otherwise you're not getting to work tomorrow. So you have this system in the middle of your architecture that everyone is too scared to touch because it's the legacy system. And everyone is very, very careful not to change because it's the legacy system, the foundation. I've literally been in banks where the legacy system has 2 people working on it and 5 open job vacancies. And the reason there are 5 open job vacancies is because it's written in COBOL. And everyone that they used to have on the team has retired or died. Now, if you work in a bank, this is horrifying, because you do not just decide tomorrow, I'll just write some microservices and replace a core mainframe in a bank. That's not how this works. And our 5th and final bias, we cannot, with our security tools, detect human risk. I'm an engineer, you're an engineer. We are hugely problematic when it comes to security. But our tools don't look for that. They're like basically regex and address. They look for common patterns and tell us a third-party dependency is out of date. So how can we take all of these bias into account and use data we have to do something smart? Now, there's no fancy tools in this. Everything you do in this talk, as a result, I have done myself with truly terrible Python, using Copilot as my little friend because I was feeling lonely. And you can do this yourself. So it doesn't matter what language you build in, I don't care what infrastructure you use, you can build this yourself in an afternoon. And I'm even going to give you at the end a link to an open source project that exists that can do some of it for you, a starting point. So we're going to move from looking at one repo to looking at software in general in our organization. We're going to move from what we're doing right now to what we have been building in the past, what we are doing right now, and what we will do in the future, because that data is always evolving, and our risk is always evolving. And we're not going to add security in here. We are going to very gently tweak the existing tools and processes you already have in your dev teams. Now, the trick to security that nobody ever tells you is security isn't about coming in and putting a magic box in the middle and saying, well done, you have security now. It's about each one of us changing our mindset slightly to accept that we want to build high-quality software and that security is part of quality. That's it. That is the root of AppSec. So if you can accept that, you're going to be fine. So let's do it, because you came here for the data, right? You're like, I want to do some data. Raise your hand if you are self-proclaimed data nerd, and you're like, yes, data. Oh, you're in the wrong room, people. Right. Okay, so every single tool you use collects data. You know this because you build software, so you know that you collect data, and if you collect data, then they must too. We are going to be pulling data that already exists in your dev tools to come to conclusions. We're going to be looking at patterns in that data. Now, I'm not suggesting you do this by hand. Dear God, no. Write yourself dirty scripts. Pull it into MySQL databases or SQLite or a spreadsheet, whatever floats your boat. We're going to be looking at diversity. How much difference is there? Frequency, how often does something happen? Recency, when was the last time you did something? Raise your hand, when was the last time any of you looked at a security tool consciously and actually went to use it properly? You're a security person. We're going to look at number, big and small. We're going to look at consistency. We're going to look for things that decrease, so get smaller over time. We're going to look at things that maintain, and we're going to look at things that increase. And spoilers, decreasing isn't always good or bad. In fact, it's all context-specific. We're also going to look at delta, the change over time. So how on earth did this talk even start? Well, I was sat at home, and I was supposed to be writing something really serious for work, and instead, I was daydreaming. And I sat there and I said to myself, is there a way you can use metadata about your software development process to identify security risks? And this was far more entertaining than what I was actually supposed to be doing, and down a rabbit hole I went. So first I started looking at project composition. So the number of lines of code, the build mechanism, is it, DevSecOps and you've got a nice pipeline, or is it built on a local machine and stuck on a thumb key and sent out there? I don't judge either way. I genuinely am an equal opportunity software person. I've worked with people who write code for oil rigs, and their deployment process is a man, normally, on a boat, physically takes code to an oil rig and puts it into the system once a year. If that's your deployment process, that is what it is. I wanted to see the delivery cadence. How often was this code being built? The technology usage. And I wanted to see it. I'm a very visual person. So I started pulling all of this data. And it was fast and dirty, as I said. It was just really nasty Python commands, but it got the job done. Because GitHub, in particular, has some fantastic, well-documented APIs. So please have a play with them. They're quite a lot of fun. I even remembered to not put my token on the screen, which is an improvement on 3 years ago when somebody in the audience decided that they were going to compromise my account. Thank you, internet friends. Okay. From there, I created a whole set of APIs where I could then pull the data. So for example, this bit here is just pulling all of the repos I have in my organization. Now, there's nothing sensitive here. I'm not pulling, the secrets of your organization. It's all just metadata, data about data. So you don't need to worry too much about sensitivity, and it all comes out in JSON format, so that's quite nice and easy for us to process. So I started having a look and setting some rules. So I want to know how many distinct technologies were used in a project. And by virtue of that, I could map the technology uses across an entire organization. Raise your hand if someone in your organization believes you just write in one language. Yeah, you don't. I promise you. Absolutely promise you. Looking at diversity of technology is really interesting. It tells you how deep your technology skill is likely to be in your organization. If you've got pockets where suddenly you've got an Elixir app somewhere in a Java shop, that's interesting. How many of you actually have the skills for that? Now, a lack of skills or a lack of awareness or individual projects that are outliers, that's interesting to me because they tend to have less people to look at them, less focus, less tooling. It also increases the chance of software supply chain risk. Now, what that means is every time you pull in a repo, you inherit some sort of vulnerabilities with it, potentially. And the more technologies you have, the more ecosystems you're having to manage and monitor. Now, I'm not saying don't use lots of technologies. I love heterogeneous technology architectures. They're wonderful. But be mindful. The more diversity you're seeing, the more complexity you get. And if you do map this, so you've got your nodes and edges, you've got your repos mapped out with some lines between them, I want you to go, right, for this one, I need to be monitoring this ecosystem over here, because it's in this technology. And this one over here, I need this ecosystem. It gives you a map of the information you're missing, the skills you might be missing. I started looking at lines of code, because obviously bigger is better, and every project should have as many lines of code as humanly possible. And we should never delete code, because we might use it later. Said nobody, ever in software. If that is you, please go home and clean up your code. The more lines of code in a project, the less likely it is that one single person is going to understand all of it. So if you've got a project in your ecosystem that is huge, you also want to see a developer community that is substantial too. You want to be seeing which parts of this are getting attention. It also means, when you think about reviewing things, it's really hard to do that on big things. So more chance you're going to miss something. Now, I'm not saying you should all just go microservices and node and just write 7 lines and be done. Just be mindful. So here's a bit of a recipe for you, if you will. I want you to try and identify your decaying projects. So decaying projects are ones that are not really being looked after anymore. So the numbers you're looking for is the project build frequency is decreasing. I'm not building it as much anymore. It used to be every week, and now it's once every 4 months. Because remember from the start, if we're not building it, we're not scanning it. And the longer it is from being built, the harder it's going to be to do any updates and changes later. We're going to look at a decreasing pull request frequency. Again, that's an indicator of change. We're going to look at the contribution community size shrinking. So if you're in a big organization and you're moving between projects and they're managing your permissions properly, you're going to lose access to repos. And you will start seeing these decaying projects get a smaller group of people, a smaller community around them. If you start seeing this, that's a big risk, not just from security, but from a resilience point of view. You've now got this massive weight of maintaining a system on the shoulders of very few people. And if something goes wrong, picking it up and dusting it off is going to get quite difficult. I started looking at pull requests in detail. Reviewer diversity. Any of you in a team where you know that 90% of your pull requests go through the same single reviewer? Yeah? As a common anti-pattern in software is we give all of the pull requests to that senior person on the team because they're really good at it. Do you know how they got really good at it? They did a lot of pull requests. When we only have one person doing pull requests, it's really, really dangerous, not just for security, but overall for knowledge sharing and for the idea that, that person's fallible. How many of you have been distracted or tired at any point and made a mistake? Or you were watching a cat video and you really should have been focusing on work, but you weren't that much and it looked fine, so you just hit, that's fine. We're looking at submitter diversity. Is it the same people reviewing as submitting? Is it people who are submitting of this personality type or this group, they submit huge pull requests versus this group and they do small ones? None of this is hard data to find, it's all there. But if you can map it, it doesn't just tell you about the security of your application, it tells you about the culture of your team. It maps how you operate. And then by understanding that, you can tweak it. We can look at that reviewer diversity, so the lower percentage, the bigger the reliance on a small group of people. How many of you hope to one day have another job? If your boss is in the room, I forgive you for not answering. You don't want somebody to be in a position where they're going to go and get a new job, but they're the only person in your organization who's done pull requests for the last 2 years. Because all that knowledge goes with them. You want them to be able to take holiday. Go and have a new adventure. So I started asking myself, okay, this is interesting. I've got data about my repos. I've got data about the pull requests, and that's interesting. But what about people? Now, full disclosure, I did a talk at Black Hat in 2015, and I wrote a human vulnerability scanner, which felt like a good idea at the time. And at the end of the talk, somebody very lovingly told me I should probably go to jail. But it did get me started on this idea that the people were actually a lot more interesting than we give it credit. But we don't talk about people in development security because it makes us feel very uncomfortable. So let's do that. Okay, so let's have a look at the people things you could measure that could tell you things about security. So, team size. Is a big team better or worse? Everyone's like, oh God, this is participation. Oh, okay, raise your hand if better. Raise your hand worse. Raise your hand if you have a hand. Fantastic, well done team. I like the third group, you're with me. Right, your team size tells me a lot. If you have large, sprawling teams, that's interesting to me. If your team is offshore or outsourced, that's interesting to me. The size of your team, do you know, there's an actual bias in psychology about population size. The bigger the group of people, the less you feel responsible for what that group does. So because there's lots of people in the space or contributing to the project, you don't need to try as hard because everyone else is working hard. Have any of you ever felt like that? You're like, oh, there's like 50 people here, it'll be fine. That's why people don't vote in elections. They go, oh, cool, well, I don't need to, I'm just one vote. It's the same, literally the same psychology. So big team sizes can be a little bit of a distraction because we say, oh, there's lots of us, somebody must be doing that. Spoilers, they're probably not, especially when it comes to a security process. Pattern of life. Now, this is where people start getting a little bit uncomfortable, sorry, kind of. What if you, Toby, you always do all your coding at 2 o'clock in the morning because you're gallivanting around the world in different time zones and having a wonderful life as a nomadic developer. Great, wonderful, that's Toby's pattern of life. But what about you? You're always in the office at 9 o'clock sharp and you finish at 5 o'clock and you don't do anything on weekends. Why is that interesting to me as a security person? Well, if Toby's account starts behaving like your account, or if your account starts looking like Toby's, or if you start looking like a crazy, chaotic mess of things that we can't quite describe, that's interesting to me. It could tell me your account is no longer your account. It could tell me that you're stressed. You know, if you start working nights and you're normally a really very methodical 9 to 5 person, that stress isn't going to lead to good choices. So looking at that data, even if it's just to raise a little flag going, are you okay? Can be really important for security. Contribution, recency, and frequency. Now, keeping projects in your head is really, really hard. There is a lot to remember. And the longer ago you committed to a project, the more fuzzy your memory is. So if you notice that, say, lovely lady in the green jersey here, if your commit frequency is decreasing, or the recency is growing, so you know it was actually 3 months ago you touched that project, it's safe to say that coming back to it is going to take longer, that they might need some more support. So we can start to preempt that. Now, we want to keep memory recent of projects, not just for security, it is really good for security, but also from a resilience point of view, because it means that we've got that institutional knowledge still flowing around our systems. Project to contributor ratio, this I call the superhero effect. You're looking for people who have access and are contributing to literally every project in your organization. This is not good. Please don't do this. It's great to have varied interests, but get other hobbies, please. If you spot somebody who has got access to everything or is inside everything, especially if they have a job title like CTO, please revoke their permissions. Tell them I told you to. They can come and talk to me. We don't want somebody who is in everything. We want people who are focused. We don't want accounts with wide access, because if they're compromised, the damage is huge. So if you see this, or if you've got too many permissions, I want you to pick one you don't like very much and give it up. Just, you know, like giving up chocolate, just a lot easier. So you'll get these slides at the end. There is a QR code right at the end, so you can download them and you can go and play with this data. We want to look at that individual contributor frequency. We want to look at that ratio. And I've provided in each case a guide of what you want to be looking for. Now, if you're really smart, do this with an API. Just set it as a little lambda. Do it once a day or once a week or something, and just create yourself a little tiny alert if something changes. Is this a glamorous, sophisticated security tool that's going to have next-gen AI? No, it's a dodgy Perl script that you wrote because some lady at a conference told you to. But it actually might be the best 3 hours you ever spend, and it's certainly a lot cheaper. So here's a recipe Like I said, I like giving recipes because it gives you something tangible to go and do. I want you to go and identify key person risk in your team. Now, to be explicitly clear, when I say key person risk, I do not mean that Toby is evil and I'm now going to monitor everything he does. Key person risk is the idea that somebody is so ingrained in something that if something happened, the damage could be really high. When we look at an individual, it's never to say, hey, you're evil or you're bad or you should feel bad. It's to say, I want to understand what you're doing and prevent anyone from accusing you of doing harm. Because if you monitor people in that way, it's actually a safe thing. Again, I know I sound creepy. You can have feelings afterwards. So you want to be looking for individuals with a high number of projects that they contribute to, individuals who are looking at a high number of pull requests. If they're the same person, this is a red flag. Individuals with a high rate of pull request submission across a number of subjects. So what we're saying is this person's everywhere and in everything. Now, if you also combine this with our earlier data and technology use, and it happens that that person's skill set is in a rare technology, and there aren't many other people with that particular skill set, that is incredibly dangerous. So those combined profiles can tell you something. They can tell you, if this person leaves, you're going to have a headache. They can tell you that this person should be mentoring other people. Like, this person needs to be sharing that knowledge. You can use this as a trigger to improve security and resilience by having more than one person, but also to upgrade your team. And then I decided, because I was doing a serious business conference talk, I should mention Conway's Law or something. Raise your hand if you know what Conway's Law is. It's okay, I have to Google it every time, don't worry. Conway's Law is by Melvin Conway. It's actually from the 70s. It says that any organization that designs systems, which was a broad definition of what a system was at that period of time, will produce a design whose structure is a copy of the organization's communication structure. Now, I'm going to butcher this a little bit to shoehorn it in, but just bear with me. Because you can start looking, as well as at your data from like your repos, and your data about your people and their patterns of life. You can look at business data. So regulation compliance, your revenue model, your organization structure, your company's health. Raise your hand, and I don't judge, if your company's had a bit of a rough year and, dear God, you wish it was over. There's a lot of that right now. These bits of our business directly impact how we build software and directly impact the security of that software. Let me explain. So, how many of you are billable by the hour? You work for an organization where you sell your services to someone else. Yep, I see you all, hands, that's fine. No problem with being a service business, I get it. There is a direct correlation between the percentage of billable hours on a project that have to be billed to a customer that's inversely proportional to the amount of security that happens. So the more you have to bill to someone else, the less security you do. And it's not because you're malicious. It's not because you're lazy. It's because your business model literally measures one thing, and that's billable hours related to a project. And that project probably has a set of functional specs. So it will be very difficult for you to say, actually, I need 20% of my time every week to look after this project, to keep it fed and watered and up to date. So if you're in that environment, I want you to think about your business model and how that relates, how that's impacting your security. Now, it's not an easy fix, this one. If you find this number is going up, you'll see a pressure to do less security. Or you're going to have to try and sell it to your customer, which is incredibly difficult. Now, I'm a bit left-leaning, and I truly believe that if you provide a service like software development, that security is an expectation, an implicit expectation from your customer. They're not paying you for it because they expect you're already doing it. Your bosses probably feel differently. So find a way to bridge that. Regulatory and compliance scoping. Raise your hand if you have to do some form of regulation. Finance people, I see you. ISO, PCI, DSS, APRA in Australia. It doesn't matter where you are. GDPR, we're in Europe. If you're not doing GDPR, what are you even building? There's an interesting thing that happens in compliance. Now, I'm a reformed auditor, so please don't judge me. But what they do is they say, okay, To keep this simple, we'll do a scoping exercise. So we'll look at which systems store which kinds of data, and we'll declare them in scope or out of scope for compliance. And the game that you play as an engineering team is trying to figure out how to get as many systems out of scope as humanly possible. You have like this one golden system over here that's like the PCI system, and then everything else is over here behind a closed door. And that's how the game is played. And they will even talk about it. The PCI DSS guidelines for auditors talk about scoping as the first most important thing. Now, what's the problem with this? Well, your organization cares about compliance and regulation because it's the license to operate. But if things become out of scope, then they can't use the same levers, the same reasons to do security. So if you have a system that is in scope and out of scope, you're going to focus the security resources on the one that is in scope for compliance, because if not, you fail an audit. If you are in an environment that does this, that has some form of scoping, I want you to make sure you find those out-of-scope systems, and you find a way to include them in security without the lever of compliance. Because it's really, really dangerous to believe that the compliance scheme is what's keeping you safe. That's the reason to do security. To give you a fun example, I once worked with a telco, and on the same systems as their payment system and customer management, they had this fun little application. Now, how many of you have ever done like a steps challenge or whatever at work, and they've tried to give you prizes to encourage you to be healthy humans? Yeah, they do that from time to time. If you haven't, please just go away from work that day. Well, this telco had written an app, an internal app, but still on the same network as everything else. And it was like a leaderboard for the staff and the teams of who was doing the most health and fitness. And over the course of a month, you could earn prizes. But this system was just for internal staff. It was just a tracker for your steps and who was going to get the chocolate bar at the end of the week. It was completely out of scope for everything. There was no dedicated engineering team, there was no budget, there was no compliance, no audit. It just existed. And it existed for 7 years without being built, without being touched, but it ran every single year, and every single year they gave prizes out. Now the problem is that that application was on the same network, in the same domain, as much more sensitive applications. Now, I want you to put your attacker hat on at the moment, and I want you to imagine a house, just for a second. Let me just segue. You've got a house in front of you. Maybe it's your house. And I want you to think of the way you would break into your own house. I want you to think about the simplest possible way you're going to do that. Did any of you just brick a window? Anyone just put something heavy through? Anyone find a key underneath a rock? Don't admit that one in this group, because I'll probably figure out where you live. I live in New Zealand. You never need to break a window because most people don't lock their doors. And if they do lock them, they helpfully put the key inside the hose reel in the garden. That's where the hidden key always is. It's inside the hose pipe reel. As an attacker, they see software systems in the same way. This isn't about going all Hollywood and going to live in a basement and hacking things. The easiest route to do this is to find the little software on the same network that happens to be externally facing because people work remotely, that happens to be on the same network. You see how this works? When we scope, when we start to neglect things, we treat them as old or insignificant, they expose us to risk. Just like that key in a hose reel, or that door that you don't bother locking because you live in a safe neighborhood, or the cat flap that you installed so close to the door handle that you can just reach inside and flick the lock. If you haven't tried that, do try it, it's fun. Development team turnover. How many of you have lost people from your team in the last year? Everyone, probably. It's just natural, right? Average teams that we work with have about 6% turnover a year. What happens if you leave a team? Well, high turnover loses institutional and project knowledge, right? They can't help you because they're no longer there. It also means that you're spending a lot more time on upskilling people and bringing them up to speed on projects than you are maintaining the projects. As seniors, we get distracted into this upskilling part. We also may start making swinging changes to our applications. How many of you have worked somewhere and you've come in and gone, what the heck is this? We need a rewrite, please. Yep. It's like every new job, you have 90 days to pick which bit you're going to get aggressively focused on rewriting. So be really mindful of that. If your organization has lost people this year, my heart goes out to all the organizations who've done that. But that has caused a security challenge. There are now accounts in your system that need to have been removed. There is institutional knowledge that is still in people's heads. There are passwords and keys that need to be rolled. And I don't say any of that with joy. There's no happiness in that, but it's reality. So sadly, think about the business and the economic situation we're in from a security point of view too. If you know that a system is very fragile and that someone's just left and they know exactly how to destroy it, maybe let's work on that. So how do we prioritize this and get going? Well, in almost every other area of security, we start with what we call asset mapping. Now, asset mapping is the idea that you cannot protect something you cannot see. Now, we don't do this in security. We treat each, oh, hello. Well, that's rude. Hello, AV person. Oh, it's back. Thank you. Oh, goodness me. That's like adrenaline. Okay, cool. All right, breathing. Right, so we can't protect what we cannot see. And so at the moment, we look at all of our projects individually, right? We don't look at how they all map together. So your first piece of homework is I want you to map all of the projects in your organization, and I want you to map what they are. I want you to graph them out, like nodes and edges graphs. I want to link them. What calls what? What depends on what? Now, I started doing the relationships in an organization. Now, this is just a high level, so object-to-object relationships, not projects. So you can see in the slide decks afterwards, it's quite small. But when you start mapping all of the object relationships in your dev teams, like the little data nerd in me gets really, really happy and wants to start talking about database normalization. But if you're looking at this like most people, it's not fun. If you work for a tiny startup, you're like, yes, I got this. There's like 3 projects, and I know all of it. How many of you work for something where if somebody asked you today to draw out all of the components and how they relate, it would give you a slight, palpitations moment? Yeah, good luck. Once you've got this map, even if it's a partial map, any map is better than none, I want you to start spotting and flagging your dormant projects. Now, that's not a big thing. I want you to just color them red if you have to. I don't care. I want you to just put a little dot next to all the ones that are no longer being built, because that is the proportion of your systems that you have no idea about the security of. And a correlation there may not be true, but often is. They're often the systems whose logs don't go anywhere central either. So as well as looking at what tooling is running on them, if they're ever building, I want you to see, well, would I even know if something went wrong with this? Does anyone know about this project anymore? Now, I'm not saying this to scare you, but knowing it is better than not. Knowing it means you can start. I'm going to set you a challenge. And it's a challenge I want you to pass to all of your team. I don't think you need to dedicate your entire life to security. I want you to give me 1 hour per sprint. That's it. I want you to spend just 1 hour of effort every sprint thinking a little bit about security. And it could be pulling one of these dormant projects up and just building it once just to see what happens. It could be updating your map. It could be having a chat about how, as a team, you could approach this. But 1 hour isn't much. You've probably wasted more than that today on your phone. Now, if you want to get started, this is a free tool you can find on GitHub. So Git Quick Stat. I did not write it, but it is great. And it will query a Git repo, and it will tell you things like the change logs, the daily status of it, the contributor frequency, all of those basic stats. It's not going to do the full picture of what I've asked you to do today, but it is a fantastic starting point. So if you're going to take a task, grab Git Quick Stats. That's really hard to say when you've got a camera in front of you. And I want you to run it on each and every project you can. And just put those stats down and look at them. Look at the data and tell yourself the story of what your software ecosystem looks like. Finally, I want you to map your people to your repos. Now, the easiest way to do this is to look at your permissions. So look at who has what variation of permissions in Git against which project. Now, we're not about spotting problems. We're just mapping people to applications and looking for bridges. Now, a bridge is somebody who links things together. There is a fabulous book by Dr. Ross Anderson from Cambridge, and it's about networks and the interconnectivity of things, nothing to do with security, really, but about how things and communities connect. And bridges are vulnerable things. They're powerful, but vulnerable. If, for example, this half of the room here is only connected to this half of the room by the lovely volunteer here, it's the only person that they know that joins them. He knows everyone. He's a very social person. Then if I was to give him $50 and say, please go and take a nice long walk across the river, these two communities suddenly lose contact with each other. The same happens in software. If you've got somebody who's bridging your repos, those key people, and they disappear, things fragment. They become further apart. So map your people to your repos and start looking for that. Your HR team are going to love you for this. Your teams will quite enjoy this because they won't have seen this before. What do you look like as a dev team? What does your people infrastructure look like? So your homework, 3 things. Map your systems. Don't freak out. You can do it. I believe in you. I want you to share by looking at the number of key person risks. I want you to look, and if you're one of those key people, stand up and tell your team about it. Do you know one of the most powerful things you can do as a development leader is stand at the front of a group of people and say, this is hard, and I don't know how to do it. Can we figure this out together? So do that. Be that person. And I want you to awaken, resurrect, it's a bit like necromancy at this point, bring the dead back from your repos. Go build the things that haven't been touched in ages. Go hunt down the source code from that outsourced project that was done by that team that one time that you've been hoping it isn't going to fail for about 6 years now. And if you can't find it, then you write it down. All the issues you find, write them down. Now, it's not about creating this massive list and being overwhelmed. It's about knowing where to begin. Security is a form of technical debt in some ways. But whereas in technical debt we might choose to delete it all in 3 months and never do it again, with security, just writing it down, even if you're not going to fix it, means if something goes wrong, you can revisit that and go, oh yeah, we knew about that. We'd made a decision. And so that institutional knowledge about risk, about problems, is not lost. It means your whole team can understand and share it. It doesn't make you more vulnerable having a list of that. It makes you stronger. So, little summary, you have more data than you can possibly imagine, and if, like me, you're looking for a distraction from what you're actually paid to do, this can be a really good side adventure, and you can call it security, and people will be proud of you. You can use data you already have to spot risk in projects, and that's a powerful thing, and you can take simple steps to reduce it. Please don't get distracted in this market by spending millions of dollars on security tools. One of the most powerful and cheapest things you could possibly do this year for the safety, security, and resilience of your projects is to look at the data you already have. Right, that's me. Well, that's actually not me. That is what AI thinks I look like, which is way better than any photo. And if you're horrible with headshots, I highly recommend doing it. If you go to that little QR code, you can grab my slides from today, and you can contact me on various social media posts and platforms and that kind of thing. If you have any questions, I have about 5 minutes, so I'm more than happy to answer them. And if not, you can find me at any point during the day, and I'm happy to have a chat. No questions? No? Oh, look, it's exciting. And they're all like, oh, God, I have to sit down. Yeah, I see you, sit down. Right, hi.
We are a service company and we work with a lot of different projects. And
yeah.
Often there's just 1 or 2 people of our company working on that project. Mm-hmm. I feel we always have a key person risk because there's just 1 person. Mm-hmm. How would you deal with that kind of situation?
So the question was about when you're in an outsourced situation, so there's only ever 1 or 2 of your team working on the projects of your customer, and how you manage that key person risk. Well, part of it is documentation. You're going to have to, unfortunately, document quite a lot of what you're doing. And the other part is, as an outsourced company, it is key person risk, but it isn't. It shouldn't be. Because the organization you're working with, part of your job, as part of that engagement, is to give them so much understanding of what they're doing that if you were to dance off into the night, that they can carry on without you. So rather than worrying about the key person risks, particularly on your side, spending time enabling your customers to make good decisions and to be aware of their software can help so that whenever you bring a new person in, they should be able to trust that information is already there because you've already trained the team you were working with to help. Hi.
How do you avoid this type of tool to be like used as like micromanaging instead of like actually improving security?
How do we make sure that the tools aren't micromanaging rather than improving security? I think, not being an idiot with them is a good start, to put it very bluntly. So for me, like I said, I'm not particularly interested in the individuals. I never really am. But I'm interested in connection and stories, and data tells stories. And I think if you went to the keynote, the AI keynote about the measuring the LLMs and their efficiency, that's another way that this is really it links together. Data tells a story. I think if you're using it as a distraction, saying, oh, I've got to run my stats once a week because reasons, and now you're missing the point. So what I would do is craft this into a story for your team. So run it once. Have a discussion. What does this mean for you? Make a plan. Set some goals, run it again a little time on, so that the tool becomes a key to telling and continuing a story, not just a handle that you're turning again and again. So a report that you get too often, so often that you can never action it, is no use to you. It's why many security tools get put into monitoring mode, because they run on every build and nobody has the time to fix all the vulnerabilities every build. So yeah, use it as a tool as it's intended rather than as a boring handle to turn. Any other questions? Hello.
I think these tools and employee motivation is important.
Mm-hmm.
I would definitely love to know more about what the lady considers micromanaging and why she feels like that.
I feel like I just started a therapy session. Trying not... Absolutely. And so I'm not going to ask you that because that's a weird question to ask for an audience member to an audience member. He can at least buy coffee first. But I'm going to talk about micromanagement and the misunderstanding. Now, security folk are often accused of trying to micromanage, to create friction, to put jobs onto people. Now, part of this comes from often we sit outside of the development team. And so we come in with our shiny box and our checklist of things that need to happen. We say, here, I got you a present. And we give you a tool, and we stick it in your ecosystem. And we say, right, you've got to run that every time now. That's a really dodgy way to change anything. And it can feel like somebody is interrupting you or micromanaging you or telling you how to do your job. If you're in a dev culture that is very autonomous, where agency is favored, that definitely feels wrong. If there's a security person in the room who has done this, what we want to be doing is respecting ritual. So whenever we put something security in, it's not about saying, I know better and here's what you should do. You can't pack somebody else's suitcase for them. It's about saying, here's what we need to do at a high level. Here's what we're aiming to do. Here's some options that I have. Can we work through these and look at these? And I think turning it culturally and integrating those cultures together is part of the key, because then it changes the perception. It becomes more collaboration than just a consultancy type of thing. But that's a very big question, and definitely one that needs a cup of tea. And if you want to follow up, please find me afterwards. Any other questions? You've all been fabulous, apart from the people who left before the questions. They were terrible. It's lovely to see you all. Please join me this afternoon if you would like to talk about UX and security, and that's a completely different landscape. And if not, it's been lovely to see you. Please enjoy the rest of your day.